All right. Well, I'm sure more people will be sliding in and joining us as we go through the introductions here. First and foremost, a quick thank you to everyone on the call so far. Really appreciate you joining us and being prompt. And a thank you to Rebecca and Karine on our marketing team for getting this all set up so that we can get this information out to engineers, architects, and designers all across the US and Canada. With us today is Corey Macy from Franke. And I guess in terms of some introductions, first and foremost, my name is Zach Allison, and I am the Market Development Manager for ATS. So we on the Market Development team can provide product training like this for you and your firm individually as well. And we set up these webinars so that we have good quality discussions with the manufacturers that join the ATS spec tool. So today, Corey Macy, the Commercial Product Manager for Franke, is going to be going over the engineered infection control products that they do have on site, but it's going to be more, application focused, which is the style that we like to take. Not necessarily diving into specifics on product, though. As always, if you want more detail on specific product, reach out to us and we can have that discussion after the session. But today is really going to focus around the purpose and design of these products for this particular engineered infection control category. As a reminder, as with many of our webinars from ATS, this will be recorded so that we do have the opportunity to post on our blog for those that may not be able to attend today. And with this particular presentation today, there are CEU credits. So we will have a code available as part of the follow-up that if you do need to register your CEU, you can get the credits for this. As with many webinars these days that we've learned to love, everyone is muted upon entry, but we will be taking a note of any sort of questions in either the chat or Q&A fields. As Corey goes through the presentation, I'll be sure to keep an eye on those. And then after we have the discussion on the application, I can also show you where you can find the product on the atspec.com website. So I guess with that all covered, thank you all for attending. Thank you, Corey, for providing us this information. I'll pass it over to you.
All right, thanks, Ed. Start sharing my screen. All right, so yeah, first of all, thanks everyone for participating in the CEU today on engineered infection prevention. So here's our learning objectives of today's CEU. First, we'll discuss the problems faced by the North American healthcare facilities related to hospital-acquired infections. We'll review technologies that have been shown to have dramatic impact on reducing hospital-acquired infections, and those being UV disinfection, copper coating on high-touch surfaces, ozone disinfection, and hand hygiene sinks. So by the end of this presentation, you'll have a deeper understanding of the benefits of ozonated water related to hand hygiene. And lastly, we'll discuss how ozonated water technologies benefit hospital cleanliness and improve patient outcomes. So first, knowing the basics, we'll discuss about healthcare-acquired infection. So an HAI is short for healthcare-acquired infection or hospital-acquired infection. We use these terms interchangeably. An HAI is an infection that you get from a hospital. So there's 4 criteria to labeling an HAI. It can meet one or all of these criteria. So it's either acquired up to 48 hours after admission to a hospital. It's acquired 3 days after discharge from a hospital. It's acquired up to 30 days after an operation, or it's acquired in a hospital if you're admitted for something else other than the infection. HAIs are among the leading causes of death in North America. In fact, when we look at Canada and the US per capita, HAIs are estimated to be the 3rd leading cause of death. The statistics for HAIs are quite alarming. Every 45 seconds, a hospital patient's infected with an HAI. Every 8 minutes, a patient dies from an HAI. On a given day, 1 in 31 hospital patients have at least one healthcare-acquired infection. And 1 in 10 hospital-infected patients will die from their HAI this year. And HAIs are expensive. The estimated Average direct cost for an HAI treatment is roughly $30,000 per case. According to a university health study, C. diff cases cost almost $38,000 to treat. The direct treatment cost for hospital-acquired infections is estimated at $45 billion annually. So the total cost of the healthcare system to families and to the economy is even higher. HAIs have a domino effect on the world healthcare system. Infected patients remain in hospital much longer before being discharged. Approximately 10% of acute care beds in urban hospitals are occupied by patients who have had increased length of stay due to an HAI. So when a patient remains in hospital longer due to one, they take up valuable bed space. New patients end up being treated in hallways, lounges, or squeezed into rooms designed for fewer patients. ER wait times are increased because the ER is stacked full of patients waiting for bed to free up, and the HAI crisis contributes to the hospital overcrowding crisis. The three most common forms of HAIs are C. diff, MRSA, or COTI. Colostrum difficile, or C. diff, is one of the most frequent infections to occur in hospitals. C. diff exists as a vegetative state inside the human body, and when outside the body, it can exist as a spore, which easily become airborne and spread onto surfaces. Alcohol-based hand sanitizers do not kill C. diff spores. MRSA is a form of staph infection that's resistant to many of the common antibiotics used to treat staph infections. And due to the resistance, they can easily spread throughout the hospital, causing alarming outbreaks. And COTI infections, or urinary tract infections, occur when patients are catheterized for a longer period of time. The CDC emphasizes proper use, insertion, and maintenance of urinary catheters in all healthcare settings. So next, we'll look at the techniques hospitals and healthcare facilities use to prevent the spread of HAIs. So this presentation was initially created before the COVID-19 pandemic hit. Hospitals have likely improved their cleaning protocols since the start of the pandemic. So when it comes to cleaning patient rooms, they're first decluttered and then cleaned and disinfected to be set up for the next patient. And this process is typically done with cloths and harsh chemicals. Manual daily cleaning takes approximately 15 minutes to do. Surfaces are spot cleaned since patients are still occupying the room. A room turnover or terminal clean is performed after a patient has left the hospital prior to a new patient coming into the room. A room turnover can take up to 30 minutes. And an isolation clean is a deep cleaning performed after a patient who has been in isolation or has had an infection has left the room. This process is longer and can take up to 45 minutes. So with all these methods, at best, fewer than 50% of the surfaces are properly disinfected using traditional cleaning methods, no matter if it's a daily turnover or post-isolation clean. Proper cleaning practices are important to help control the spread of infection in hospitals and healthcare settings. So we'll be exploring the technologies that can help prevent healthcare-acquired infections. These are emerging technologies, not because they're new, but because their use in healthcare settings is becoming more and more prevalent. So first, we'll review UV disinfection. UV disinfection is not new. Its antimicrobial properties were discovered about 200 years ago. UV light has been used for air, water, and surface disinfection since the late 1800s. Pictured here, it is Feinson's phototherapy apparatus being used to treat skin ailments in the late 1800s. Studies have shown that UV disinfection has a dramatic impact in reducing HAIs. UV light will disinfect all surfaces, and it's extremely efficient when used in conjunction with traditional cleaning. Rooms disinfected with UV have shown reductions in HAIs by over half. There's a huge burden on the environmental services cleaning staff during outbreaks. A few slides ago, we noted that the average cleaning time for a terminal clean is about 3 times of a daily clean. This graph shows the overtime hours for hospital terminal cleans. The data represents the number of hours one hospital invested in cleaning each month. The 2 spikes on the graph note the increase in terminal cleaning hours during a norovirus outbreak. After UVC disinfection technology was added, the number of cleaning hours dropped. So with fewer HAIs, there's fewer terminal cleans required. From a hospital administration point of view, the potential payback for such a system is evident. So this is a graphic representing some results of studies performed on C. diff and how difficult it is to remove from hospital rooms with traditional cleaning methods. Before manual cleaning, patient rooms were tested for the presence of C. diff. 7 of 21 rooms tested positive. After a manual cleaning was performed, 5 of 21 rooms still tested positive. After UVC disinfection, none of the rooms tested positive for C. diff. So UVC disinfection is a very effective neutralizer of this persistent bacterium. So next we'll review how copper can be used in healthcare applications. Like UV disinfection, copper has been known to be antimicrobial for a long time. The Egyptians were the first to mention the antimicrobial effects of copper in 2600 BC. They used copper vessels to sanitize drinking water and also to treat chest wounds. Copper is EPA registered as a pesticide and can reduce the CFU, or colony forming units, by 99.9% in less than 2 hours. Here are some real-world examples of the reductions of surface pathogens that occurred when hospitals changed high-touch surfaces to copper. In this cancer center in New York, they changed the bed rails, food service tray, and IV stands to copper-coated surfaces. And by doing so, it reduced pathogens on those high-touch surfaces by 97%. In the second photo, notice the high-traffic touch surfaces are copper in the room on the right. The HAIs were reduced by 58% in the Ralph H. Johnson VA Medical Center in South Carolina. Copper surfaces are a passive way to reduce the bacteria on high-touch surfaces when used in tandem with cleaning. It's quite effective in lowering HAI occurrences. And here's a real-life non-healthcare example of a very high-traffic area. Grand Central Station in New York City. 750,000 people pass through Grand Central Station every single day. Grand Central Station opened in 1913, so some of these fixtures can be over 100 years old. Some high-touch surfaces like handles, handrails at the Grand Central Station are made of copper. So here swabs are taken on a few high-touch surfaces, and you can clearly see the difference in CFU counts on copper and the other high-touch surfaces. Comparing the CFU counts on copper surfaces and wood surfaces, you can clearly see that lacquered wood definitely does not kill bacteria. Here are some examples of some copper touch products available on the market today. Antimicrobial copper medical equipment includes stethoscopes, door handles, kidney trays, IV towers, food trays, locker liners, handles on various equipment. I've personally seen copper-coated door handles, toilet seats, and grab bars in hospitals and healthcare facilities. So moving on from UV and copper disinfection, we'll review some ozone technology for infection prevention. You may see a recurring theme here. These technologies are not new. Ozone's been used for water treatment for centuries. Ozone's a powerful and unique water disinfectant. Ozone's extremely germicidal and rapidly destroys any waterborne viruses and bacteria with nearly unmatched speed. Like chlorine, ozone oxidizes the bacteria and protozoa upon contact. The ozone penetrates the cell walls of the microorganism, rupturing them on a structural level. Unlike UV disinfection, there's no reduced flow rate for extended contact time required for disinfection. Ozone works in a matter of minutes. Ozonated water is non-toxic, and the ozone produced reverts back to water within 20 minutes or so. Ozonated water is extremely effective at killing all forms of bacteria such as Legionella, E. coli, C. diff, and more. Here are the most common bacteria that thrive in plumbing systems. Obviously Legionella, Candida auris, which is a new superbug, E. coli, C. diff, and more. And even mold and mildew form organisms which love water. Here's an in-field example of the problems caused by mold and mildew growth in a wet environment. This is the inside of a hospital ice machine. A mere 3 months after a deep clean, you can see the buildup of mold and mildew and yeasts. This type of buildup can be found in ice machines in hotels, cafeterias, gas stations, and restaurants. Some hospital ice machines use ozonated water for disinfection. This is the inside of an ice machine months after deep cleaning using ozonated water. So you can notice here, there are no signs of mold or mildew. So we have a solution to help kill waterborne pathogens. And that's by using ozonated water for hand hygiene. So what if you could wash your hands with water that was twice as powerful as bleach? You could eliminate the sink as a source of infection for bacteria. There's a university study performed on hand wash studies on untrained participants. For the large percentage of people that only use water to wash their hands, the improvement in hand washing is evident. Tap water and mechanical action will remove about a third of the bacteria from your hands. Using soap and water showed removal of just over 61% of bacteria. And by using the same methods with ozonated water, over 80% of the bacteria was removed. By no means are we recommending not to use soap. This is just illustrating behaviorally, those patients in hospital rooms that don't use soap, there's a potential impact here. So a study was done in patients using RFID tags and showed that those patients only washed their hands about 70% of the time. And of those that do wash their hands, only about 30% of them use soap, and they're only lathering for about 10 seconds. Any bacteria left on their hands can continue to grow and double in less than 20 minutes. So ozonated water.
Just to jump in there, we had a question coming in from the chat on the ozonated water topic, Corey.
Sure.
They're wondering whether or not the ozonated water affects the health of end users, especially in the ice machines.
No, it's dissipated by the time it dissolves in ice. It's very, I think in the ice machines, it's only about 0.2 ppm, a very low amount. So there's no effect to the health.
Yeah, I think that's been one of the big questions, seeing this ozonated water come up more and more often, is how quickly does it dissipate, right?
Okay, so we'll talk about another benefit of ozonated water, and that's reducing the biofilms in hospital wastes and traps. Excuse me. So it's been known for decades how important hand hygiene is to prevent the spread of bacteria and disease. Hospitals are designed with hand hygiene sinks placed throughout the hospital to help control outbreaks. Unfortunately, in some cases, hand hygiene sinks have actually contributed to the HAI problem. So if they're poorly designed, hand hygiene sinks have been shown to harbor and spread bacteria. The story behind the use of ozonated water for hand hygiene. So between 2004 and 2006, a prominent hospital in Toronto experienced a deadly contagious Pseudomonas outbreak. This led to 17 deaths and 36 patients developing some serious illness while under the hospital's care. Another prominent hospital experienced 66 patients infected and colonized by pesky drug-resistant bacteria called Klebsiella oxytosa from the fall of 2006 to the spring in 2011. So it was a highly publicized instance of where an outbreak was traced back directly to a sink. And that's when we decided to take action. So here's another research done by University of Virginia in 2017, proving bacteria can flourish in P-traps of hospital sinks. They can also climb up to where the point where they reach the drain area. Then all it takes is a splash of water and the bacteria get splashed and they go wherever they land. It's been identified as one of the root causes of the outbreaks of antibiotic resistant bacteria. This research has also found that bacteria can climb very aggressively up the pipe, an average of 2.5 centimeters a day or an inch, and reach the drain directly within around 7 days. In addition to the benefits of hand washing, the larger benefit of ozonated water is that it'll help keep the sink trap free of bacteria and biofilm. Water can splash from the faucet into the sink drains, which have been found that they're the perfect breeding ground for bacteria. They're constantly fed a rich diet of biological material. And furthermore, as we've learned with the research mentioned prior, once a sink waste is contaminated, the biofilm can grow an inch a day through the plumbing and contaminate other sinks throughout the facility. So once contaminated, they can splash this bacteria into the air and onto users using the sink and the nearby surfaces. So it made sense to use ozonated water for hand washing. Ozonated water will help kill bacteria even if soap is not used. It improves the effectiveness of hand hygiene regardless of the technique being used. And it's effective as it mixed oxidants in the water run through the waste. It also helps keep the sink waste free of bacteria and biofilm. And at the bottom is an example of how a hand wash sink in a patient room. It has a laminar flow spout with ozonated technology built right in. So this study was presented at the SHE, which is the Society for Healthcare Epidemiology of America, at their national conference in 2018. So contaminated sinks and drains are rapidly emerging as a cause for healthcare-acquired infections, particularly in intensive care units. Drain contamination is particularly difficult to eradicate due to their propensity for biofilm forming and piping. So this testing was done at the Cleveland VA Hospital, and it studied the effectiveness of ozonated water in eradicating the bacteria, as well as a new concerning superbug, Candida auris. Their study demonstrated total elimination at the strainer after 2 days of use, and total elimination of the entire trap within 9 days. And they concluded that this technology has the potential to reduce the number of sink-associated infections in hospitals. To close out this section on hand washing with ozone and mixed oxidants, we'll address some frequently asked questions. The water is safe to drink. For infectious control reasons, hand wash basins are not to be used as a source of drinking water. Secondly, warm water is not pleasant to drink. This process does change the water chemistry, but it's well within the levels of potable water systems. The water produced by the sink won't corrode pipes. The levels of ozone produced in hand washing applications are extremely small, only about 10 parts per billion. And at temperatures used for hand washing, they have a half-life of only a couple minutes. Ozone lasts, it needs cold water to last a little bit longer, closer to 20 minutes, and then warm water for hand washing, it dissipates very quickly. So that leads into the other question. Yes, does water temperature matter? And yes, if only producing ozone. Cold water is much more effective, such as the ice machine, but mixed oxidant production is not affected with water temperature for hand washing. Ozone and mixed oxidants are generated electrochemically. So depending on the electrodes used, the result is either ozone only, like the ice machines, or ozone with mixed oxidants, such as the hand washing. Colder water will produce more ozone and a longer half-life, and warm water will produce some ozone. However, the other mixed oxidants produced are not as sensitive to water temperature and account for the majority of the efficacy in reducing pathogens. And lastly, ozone is not added to the water. It's created in this application electrochemically. So ozone molecules revert back to water, and the mixed oxidants will have a reservoir effect. So since it's created electrochemically, there's no danger of off-gassing.
Let's just pause it there. Just wanted to see if there is any questions coming in on ozonated water from the group. It seems like a good point to pause. Any questions coming in from the chat? All right, well, I guess, how do you do it with a big system is, I guess, the next question that's come in.
Yeah, it wouldn't be possible with a big system with this technology because it's an electrolytic process. You're creating some gas within the chamber, so it has to be done after the solenoid valve. It has to be open to the atmosphere.
Right, so more of a point of use type installation is the plan.
Very small amounts being produced, and it has to be done point of use.
Perfect. All right. Well, I guess for now we'll continue on.
So, why the urgent need in healthcare now? So, in North America, the annual costs of HAIs are estimated at about $45 billion per year. They account for more deaths than car accidents, breast cancer, and HIV/AIDS combined. It's led to long-term disability and in the increased resistance of microorganisms. Traditional cleaning methods are notoriously inefficient for decontamination in a healthcare environment. But experts feel the adoption of these technologies, UV disinfection, copper touch surfaces, ozonated water, can help effectively reduce the risk of HAI by 80% and drastically minimize the number of HAI fatalities. It's frequently stated that in healthcare, it takes 17 years from innovation to implementation. The hospital overcrowding crisis of today, the ongoing HAI crisis, means the time for action is now. And unfortunately, during this presentation, 80 patients were infected with an HAI and 7 have died. That brings us to the end of the presentation. Open up for any other questions.
I guess I jumped the gun a little bit in terms of where I paused us there. We did actually have another question come in beyond specifically for hand hygiene in hospitals and reducing hospital-acquired infections. The other applications that you might see in it, is it long-term care or more senior private residence? Is that an application that could work as well?
Yes, it could. Yeah, we've had interest in long-term care. We've seen other companies explore dentistry as well. There's a lot of benefits for dentistry infections because it is safe and very effective in killing bacteria. So they're using in some dental procedures as well.
Oh, interesting. And one of the other questions came in, also, I guess also laboratory. Would that be, I guess there's often in laboratory and pharma, there are specific feed water requirements, right? Would the ozonated tie into that?
I'm not sure I can comment on that. I'm not sure the requirements for the feed water, so I don't think I could advise on that.
Interesting. Yeah, because there are quite often maybe like a reverse osmosis level of contaminant removal required. So we may have to go one by one in terms of the fixtures to be used there. Another question coming in, what would be the approximate capital cost per sink? And I think it's likely better to give this in levels and versus just an ozonation with faucet and the full hand hygiene sink package. What would you say there?
That maybe we can get the contact information, get someone from sales to reach out. I'm not, it's not double the cost of what a hand hygiene sink is, but I'm on the product side, not the sales side, so I don't want to misquote costs.
Yeah, that's a good point. I will say from my experience, the hand hygiene sinks compared to other hand hygiene sinks on the market are fairly standard. They're all in the same ballpark. But we'll take note of the person reaching out on that, and we'll reach out to you separately. Thank you for the question. And this one's a bit of a curious one. What type of device is needed to handle a basin? So I think what they're looking at there is can you use a typical laver basin and put the ozonated water in it, or is it only available in the combination?
No, there is a product called OzoFlow that is a retrofit tap that has all the mixed oxygen and ozone generation that fits in the housing underneath the sink. If you have something existing, and then you can just replace the tap, and that's what triggers the unit. So it doesn't have to be in combination with that with the white sink. It can be a retrofit.
Yeah, maybe we just need to match the existing hole punching, correct? Perfect. And then circling back to earlier in the presentation on copper accessories, is there any other information that you're able to provide there? Would that be even, I guess, a manufacturer that they may look to, or is that coming from anyone that you know in the market?
For the copper accessories, I believe Qvero online has a link to some manufacturers and products through their website. So Qvero, Vero, search online, you can find them there.
Perfect. And do you know if MOH supporting additional capital cost?
That I'm not sure.
Yeah, that hasn't come up for me as well. So thank you for the detailed questions on the cost structure. We'll be sure to reach out to you individually to make sure that we answer any of your specific questions there. So I guess one final thing will be regarding how do you find some of the products for ozonated, hand hygiene support? And with that, that's why Franke is paired with ATS Spec. So I'll share my screen just very quickly here. If you want to cancel. So if you're unfamiliar, atspec.com is a product selection site of which Franke is a sponsor, and Franke does have these infection prevention products. You can reach it just by going to www.atspec.com, and it's all a free login for those in the design industry. So you can see I've already created a project here this morning in preparation. And what you can do is hit this little plus button once you have a project file, and you can add different products to your selection. You have a search field here that you can search by model number, if you happen to know the model number right off the top of your head. You can search by series. So if we wanted to search for, say, the category name or the brand name of the product, you can search for the MediFlow. And then we can search by category, which is my personal favorite. So for a basin like the basin or lavatory that would be used for the hand hygiene sink, we can get into that category here. You can see we have all sorts of filters on the left side here. And I'll start by reducing down to the Franke. And then we can search by mounting type. So let's do a wall hung basin. And then what I'm gonna do is just show all, so I can see the 20 different basins Franke that fit, and you can see we've got a couple of different hand hygiene sinks available here. And these could be paired with the OzaFlow faucet and ozonated water type product. And we also do have the MediFlow, which is the product that Corey showed earlier that includes ozonated water assembly just below the shroud here. All the ATS spec information or ATS spec products has all the product information here, so you can make an educated decision. Does this fit the space of the area? What other components do I need? Recommended transformer. You can configure your product as well, so you're not just getting a generic spec sheet, although that is available here through the view spec sheet. But I can choose, whether or not I need the shroud as a knee covering. You can choose optional components like the programmer or the MediMix preset thermostatic mixing valve, because as Corey mentioned, the water temperature is pretty important for the ozonated water assembly. And we can hit add to drawing. And this is going to add it to that spec package that I started putting together earlier. The ATS site is also going to always recommend additional components that may complete an assembly. So a basin may need a faucet, or in this case, a trap and a carrier. I can hit skip anything that I want. So if I do wish to include the carrier, then I can do so. And I can hit add to drawing, or I can go directly to the complete button and just add the individual product. In this case, I'm going to hit add to drawing on the carrier because the carrier is specifically designed for the Franke sink product. And then I'll hit complete. And you can see, though I've already added some scrub sinks, a version of the MediFlow is already in this package, and a couple of the hand hygiene sinks that could be used as well. You can see I can label everything that I want in whatever form that I want. I can call this HHS1. I can move it around the project file to make it show up first. And it'll automatically update and bump it up to the top. And then once I've got everything I need, I can hit download and get this in a variety of output formats, which is really one of the best features of the ATS spec tool. You have a customized PDF package, some product brochure to show you larger images and shorter details, a fixture schedule that can be copied directly into your CAD or Revit file, 3 different types of written specs, the manufacturer cut sheet together, as well as the Revit for the entire project that you may have. And finally, the CSI 3-part spec. Now, to respect everyone's time, I did download these ahead of time just because I wanted to skip through it, but it's a very quick and easy download process. Here you can see the CSI 3-part spec. So you can see it gives you a generic general section. then a detailed product session. And all of these formats from ATS are open and editable. So if you do need to put in, alternates for your scrub sink, then you can do so. You can copy and paste as much or as little of the information from the spec package into your project. Similarly, we do have the fixture schedule I mentioned. Nice detailed fixture schedule with columns that adjust to the product that you've selected. And one thing you'll notice as well is that it'll automatically download in different tabs depending on what product you have. So if you have accessories, plumbing fixtures, drains, backflow, whatever else you might have, it'll download with individual sections depending in the schedule to match the needs most often seen in the market. And finally, some of my favorite is the PDF packages that do show a nice customizable intro package, and then the larger product image with the product details like model number. If you have something like flow rate, might show up there as well. So great for early on in your project design phase, where maybe you're debating between which hand hygiene sink you want. You can present these at your meeting and have a good discussion surrounding the product. And of course, the format that we're most commonly known for are combined cut sheets, where if you have multiple manufacturers in a package, like a faucet and all the other components that may go with a surgeon scrub sink, they would all show up here on one page, combining the information that may take 5-6 manufacturer spec pages to discuss. This gives you a nice clean view of the product selected in your project. And of course, all free and easy to use for architects, interior designers, and engineers, sponsored by our manufacturers that also put on these great product sessions. I guess double check and see if there's any final questions in the chat, and it looks like everyone had their questions answered. So thank you very much for attending. This again will be recorded, so if you have questions after the fact and you want to review, it'll be available in the blog section on our atspec.com website. We'll have a follow-up going out to everyone that attended to make sure that you have access to register your CEU credits. And we'll have more sessions coming soon. I believe next week is a session from Zoller on pump sizing. And after that, we'll be doing a ligature-resistant product for the behavioral applications discussion. So lots of great content coming in the future. Thank you, Corey, for your time. That was a great discussion. I really enjoyed it. Certainly a lot to learn on the HAI side, and really showcases the need to get the right product for that application, so that you're making sure your design is safe. Well, with that, we'll let everyone get back to their lunch hour or whatever meetings they have to attend. If you have any follow-up questions, I've been Zach with ATS, Zach, Z-A-C-H, at atspec.com. And Corey will be available through the follow-up as well. Thank you and have a great rest of the day.